Hello everyone. Today we will solve one more numerical. This numerical will involve the design of the V-belt system when the V-belt system has to transfer 20 kilowatt of power from motor to the compressor. The center to center distance between the pulleys is specified as 1 meter. Cross section of the belt is given in this figure. Then the density of the composite belt or the belt material, it is specified as 0.97 gram per cc, which is centimeter cube or cubic centimeter, and the permissible tension in the belt is 850 Newton. So as per our usual practice, first of all let us solve what are the given entities. Some more data has been specified in the table as well as some data is to be extracted from the diagram. So let us proceed. So the first thing which is given is the kilowatt, which is 20 kilowatt of power which is to be transferred. Then center to center distance C is 1 meter. The density of the belt material rho, it is 0.97. This is gram per cc or cubic centimeter. Maximum tension in each belt, maximum permissible tension P1 in each belt, it's 850 Newton. Then the data which can be extracted from this table is that for motor pulley, which is the smaller pulley, so diameter of the smaller pulley is 300 mm, while diameter of the larger pulley is 900 mm. Afterwards, the rotational speed of smaller pulley is 1440 rpm, while rotational speed of the larger pulley, capital N, it is 480 rpm. Then coefficient of friction in both the cases, it is equal to 0.2. It is 0.2. Then actually there is one more data which is given in this figure. The data tells us that theta is equal to 40 degree, where theta is the angle of V belt. This understanding will be necessary at certain step. Now we can proceed with the solution. So let us first understand what will be our approach towards the solution. How should we proceed towards the solution? We are supposed to find out the number of V belts required. So it means that designer is still doubtful that whether one set of belt will be sufficient to transfer this 20 kilowatt of power, which means that firstly we will have to find out the power which can be transmitted by one V belt. The power that can be transmitted by one V belt. So on the basis of this, if we come to know that okay, it is greater than 20, which means one V belt will be sufficient, otherwise we might have to use multiple V belts. So that's the doubt in the mind of designer. So first of all, we have several equations. Whenever we are solving the V belt numerical, we should know the equations which are available at our disposal. The first equation, which is P1 minus mv square upon P2 minus mv square, it is equal to exponential of the term f alpha divided by sine of theta by 2. So in this there is a relationship between P1, P2, M and V square. So out of these we need to find out which are the known quantities and which should be calculated so that we can arrive at the value of P2. Why? Because once we know P1 and P2 both, as well as the velocity, the linear velocity of the belt, then the amount of power, the amount of kW that can be transferred by one V belt, it can be calculated with the help of the equation P1 minus P2 into the velocity of transmission divided by 1000 to convert that watt into kilowatt. So once we have that, like I said, let us say this answer comes out to be 8 kilowatt, which means we will need more than one belt because total power to be transmitted is 20 kilowatt. So this will be our approach of solution. We will go towards determination of P1 and P2. But right now what we see is that the mass of the belt per meter length, this M, Remember, in this expression, this m is mass of the belt per meter length. It's not only in kg, it is for per meter length of the belt. And anyways, in the problem statement, length of the belt has not been specified, so we can assume that length is 1 meter. So in this case, mass of the belt has not been given, so first of all we will have to find that out. So now we will proceed towards the solution once the approach is clear. So the first thing that we need to calculate is mass of belt per unit length or per meter length being specific. Okay, so the basic understanding is that mass is nothing but whatever is density multiplied by whatever is the volume of that belt, because density of the material has been specified, and as we know, volume of the belt is nothing but the cross-sectional area of that particular belt multiplied by the span or length over which that cross-sectional area has been spread. So we have been given this cross-section of the belt, and this cross section does not allow us to calculate, because in this case B2 is the unknown quantity. So first of all we will have to find out what exactly is the magnitude of B2. So let us resolve this diagram. Let us actually break it down. Sorry, excuse me. Yes, so let us actually break it down. So let us say this is the trapezoid for which the unknown entity is B2. So please bear with my drawing, it's not very good. Okay, so this is the B2 parameter. So if we divide this diagram properly, so what do we find? This is one triangle, one right angle triangle, and this is the second right angle triangle. So this B2 span is still unknown to us, but because that theta was known to us, if we split that theta, so then we get this angle equal to 20 degree as well as this angle equal to 20 degree. Now let us say I split this, so and I name the points. Let us say A, B, C, D, E and F. These are the points with which we are dealing. Okay, now we see that this CDE is a right angle triangle. So if we take tangent of 20, so it will give us tangent of 20 is equal to CD divided by the height, the adjacent side, so that is equal to EC. Fine. So now we know something about this side EC. This is known to us. This is 14 units or 14 mm being precise. So at that point this EC is known to us. So which means that tan of 20 is equal to CD divided by 14. So it means that if I want CD, it will be equal to 14 tan of 20. Also one more thing, whatever is the magnitude of this CD, it will be equal to the magnitude of AB due to symmetry. So this is also equal to AB. Now what the diagram tells us, that if I want B2, so B2 is nothing but total base of this trapezoidal divided minus AB minus CD, or simply I can write that if I want B2, it will be whatever is your total base, which is 22 units and then 22 mm minus 2 times, or minus we can simply say AB as well as CD. And as we have already deduced that AB and CD are equal to 14 tan of 20, so I can directly write it as 22 minus 2 times tan of, sorry, it will be 2 times 2 multiplied by 14 multiplied by tan of 20. So you can calculate this entity in your calculator. It will come out to be 11.81 mm. Why we were doing all this exercise? Because we wanted to have the dimension B2, because on the basis of this B2 we will be able to calculate this area of the trapezoidal. So that is why we can calculate this total area. Let us say this trapezoidal is called as ADEF, or simply the cross-sectional area of V belt. So the cross-sectional area of V belt, it is equal to, because it is a trapezoidal, so half of summation of the parallel sides. So the topmost parallel side, it is 22 and the bottom parallel side that we just calculated, it is 11.81 multiplied by the height of this trapezoidal area, so that is 14. So the cross sectional area that was necessary for us, it is 236, my mistake, it is 236.67 mm square. Or because density has been given, this density, it has been given in gram per cc, so we need this area in centimeter square, so that gives us 236.67 into 10 raised to minus 2 centimeter square. Okay, so now this area is available with us. We can proceed with the calculation of mass. So mass m, it is equal to density multiplied by area multiplied by length of the belt. Length we are going to consider 1 meter. So the density is 0.97, area 236.67 into 10 raised to minus 2 centimeter square. Now 1 meter of belt length means 100 centimeter. For your understanding, let me just put down all the units. Unit of this 0.97, sorry, yes, unit of this 0.97 is gram per centimeter cube. This one is centimeter square. This one is centimeter. What I will do, okay, see this, 1 second, I will reorganize this. Okay, so its area, unit of the area is centimeter square, and this is 100 centimeter per meter. Then when we are cancelling the related terms, for example, this centimeter square and this 1 centimeter in the numerator, they will create centimeter cube. So automatically centimeter cube in the numerator and centimeter cube in the denominator will be absorbed. What remains with you is gram per meter. But we need mass of the belt in kilogram per meter. So we will convert this gram into kilogram by multiplying it with 10 raised to minus 3. So this will be 10 raised to minus 3 kilogram, and these are there in 1 gram. So again this gram will be absorbed from numerator as well as denominator. So what remains with you is the entire product of all of these quantities, and the unit will be kg per meter. So it tells you that the mass of belt, it is equal to 0.23 kg per meter. Okay, so now that is sorted. So m is obtained. Now we can proceed with our expression, the expression of relationship between P1 and P2. So these two equations, they now can be solved. We need one more term to be solved. The term is exponential of f alpha. So first of all, we will need, see, we have to solve exponential of f alpha divided by sine of theta by 2. So in order to solve this term, we already have coefficient of friction as 0.2. Now we will need to calculate the alpha for the smaller pulley, which is equal to 180 degree minus 2 times sine inverse of d minus d upon 2c. d minus d upon 2c, where capital D, small d are given, small c is also available, the center, sorry, c is also available, center to center distance. So 180 minus 2 times sine inverse of 900 minus 300 divided by 2 times the center to center distance is 1 meter, so that is 1000 mm, because both the diameters have been considered in mm. So now when you solve this term, the alpha s, it comes out to be 145.07 degree. Alright, now we have this answer in degrees. We have to convert it into radian for usage in this expression. So we will not use degree in there. So we have to convert it 145.07 into pi by 180. So in radian, it comes out to be 2.53 radian. That is the alpha s, which we will be using in the expression. Okay, now once this is obtained, theta is available, f is available, alpha is available. So now we can simply calculate exponential of f alpha. So exponential of, actually what I will suggest, you directly put everything in the calc and directly you calculate, let the calc do the work. So exponential of f alpha is 2.53 entire term divided by sine of theta by 2, so that will become sine of 20 degree. This entire term you can put in the calc, so this term comes out to be 4.4. So ultimately you have the right hand side of the equation as well. So now I will put down my equation as p1 minus mv square upon p2 minus mv square is equal to e raised to f alpha divided by sine of theta by 2, so that is 4.4. Now let us substitute values of all the known entities, but remember we still do not have the velocity, so let us also calculate the velocity. Velocity v will be equal to, because we are converting the rotational speed into linear velocity, so pi dn upon 1000 into 60, because we have to convert that rpm into rps. So now pi into, let us say we are taking diameter of the smaller pulley, so it is 300, speed of rotation is 1440 divided by 60 into 10 raised to 3, or 60 into 1000, 60,000 in plain language. So the velocity comes out to be 22.62 meter per second. Okay, so now the velocity has been calculated as well. Now we have most of the parameters known to us. If we observe carefully in this equation, actually the position right now is that we have understanding about P1, we have mass, we have velocity, which means we have mv square, and also we have the right hand side. So immediately we will be able to calculate one equation, one unknown, we will be able to calculate P2. So now P1, which is known, which is specified as 850 minus m, mass is 0.23 kg per meter, velocity v 22.62 squared mv square divided by P2 is the unknown parameter, again mass is 0.23 kg per meter, velocity 22.62 bracket squared, that is equal to the term on the exponential term on the right hand side, so it is 4.4. Let us solve this. When you solve it using your calculator, the answer, one second, yes, the answer that comes out to be for P2, so the P2 will be equal to 284.11 Newton. Just do it in your calculator, you will arrive at this answer. Doing it in calculator is not a big task, just developing that thought process, that how to approach the solution of the problem, that is the core understanding, and then calculation remains just only as a formality. So now you have both P1 and P2, so now you can calculate the amount of power that can be kW for each belt, kW for one belt. It will be equal to your basic formula, P1 minus P2 multiplied by V divided by 1000 to convert watt into kilowatt. So P1 is 850, P2 is 284.11 multiplied by velocity 22.62 meter per second divided by 1000. Now when you calculate this kW per belt, it comes out to be 12.8. You can do this in your calculator. So now what is the meaning of this figure? What is the meaning of this number? It tells us that one single V belt is able to transmit 12.8 kilowatt of power. 12.8 kilowatt of power, which means, but the total power to be transmitted, it is 20 kilowatt, which means one belt will not be sufficient, and that is why number of belts required, which was the core objective of this problem. So the number of belts required, which will be equal to total kilowatt to be transferred or to be transmitted divided by the power which is transmitted by one belt. So that is equal to 20 divided by 12.8. So if you calculate, it comes out to be 1.56, or simply you can say that 2 belts are required. Two belts will be required. So that is the complete solution of problem. So I hope this was useful to you. We have just made use of basic equations and the available quantities, and on the basis of that we have calculated the unknown quantities. Let's do one more numerical in the next lecture. Thank you.